So we're starting our topic of linear relations. So we're starting with what makes an equation a linear equation. So only thing that you need to look for is if the power of the unknown in our equation is 1. So when we have an unknown, it could be an x, it could be an a, it could be a y. If we don't have any powers on top, that means there is a 1, power of a 1 there. So when we have a power of a 1, we don't write it down. So this one over here, our unknown here is x. X has a power of 1, so that's a linear. So is this one, our unknown is a. So is this one, our unknowns are x and y, and they all have powers of 1. Same with this one over here. Yes, it has a fraction, but that has nothing to do with the power. The power of x in this equation is still 1, whereas these two have powers of 2 and this has power of 7. So those are not linear equations. Obviously, in the past, we learned how to solve linear equations, and that's to use the inverse operation. So example here would be to find a, we should get rid of this plus 3 by taking 3 away on both sides, and get rid of this 2 by dividing both sides by 2. However, in general maths, we are allowed to use the CAS in all of our assessments, so we should be utilizing that as much as we can. So going forward, you will only be required to solve linear equations using the CAS, so we'll practice that. So the way to do it is to go into your, let me just make this a little bit smaller, go into your calculator or your CAS, go into calculator mode and go into menu, algebra and solve. And in here, you need to just carefully type in the equation, and you need to type in the entire equation, including the equal sign, like so. And you follow it up by putting a comma there and writing the letter that you're trying to solve for. And the letter we're trying to solve for here is A, so we write A at the end and press enter, and it will tell us what A is. So here A is going to be 0.5. The next one here as well, if you were to solve this by hand, there's x's on both sides, there's a fraction there, so there's a fair bit of work to do. So instead of doing that, we'll just be using the CAS to solve. So again, menu, algebra, solve, and you just carefully type in this equation. A fraction on the CAS can be written as doing control and division, then it gives you a fraction. And you just go x on top, on the bottom you have the 2, and on the side you plus 4 equals 3x, and follow it up by putting a comma and what you're solving for. In this case it's x, and it does it for you in one step. So x equals 1.6. So as you can see, if we have a linear equation using the CAS, it's fairly straightforward to solve. So the challenge of this skill would be to construct the equation. So when we're given some context but not given the equation, coming up with the equation would be the challenge, because solving part can be done on the CAS. So here are a few examples that we're going to attempt together, and here are the steps we're going to follow. So first, after understanding the context of the question, we'll be defining the variable that we're solving for, and then write an equation, and then solve using the CAS to get the answer. So this first question, we don't have to define the variable. It's given to you as x, and it obviously is this side length of this triangle. and it tells you the perimeter of this triangle is 28 units. So perimeter is all of these lengths added up together. So we know when we add, we know from the context of the question, when we add 4, 7, and x all together, we have to get 28. Now you can just put that straight into a calculator and do solve, or you can just do 4 plus 7 first, so making it into 11 plus x equals 28. And you can put this in the CAS menu algebra solve to solve for x, and it should come out to be 17. This next question, it says that if we add 7 to a certain number, the result is 49, and we are asked to find a number. Here we're not given a variable to represent this number we're solving for. So our first step should be to defining the variable. So let's say I'll make n as a variable. You could do x, you could do a, you could do any letter as long as you define it. But I'm just using n to represent this certain number that we're solving for. And then we can then write an equation. If we have a number and we add 7 to it, we know the result has to be 49. That's what the question's telling you. And then from here you can use the CAS to solve, and it should come out to be 42. Alright, the next question, it says that we have a van that we're hiring at a fixed charge of $56 plus $80 for every day. And we have a budget of $500. How many days can we hire the van? So again, we obviously are looking to construct a linear equation here. And defining the variable, we need to think about what we're trying to solve for. We're trying to solve for how many days. So I'm just going to use y to represent the number of days that we can hire this van, and then write the equation. So here we know we have a fixed charge of $56 to start with, so that's just fixed and that doesn't change. What does change every day is this daily charge, which is $80. So on top of this, we have $80 that gets charged every day, and we don't know how many days, so let's just write y here because we don't know the number of days. And what we do know, however, is that we can only make it equal to 500 because that's all the money that we have. And this is our linear equation for this question, and we use the CAS to solve it. So if you go into CAS, we go menu, algebra solve, and we go 56 plus 80y has to equal to 500, and we're comma y because we're solving for y, and it tells us that it's 5.55. So then a question like this, where it has a lot of context, we need to think about what this number represents. So this is number of days, and we know every day gets charged $80 per day. And as far as we know, that we can't hire this van for like half a day. This means that we can, yes, hire this van for 5 days, but we can't really do 6 days because the answer that we got is 5.55. So then we need to understand that we can only hire the van of maximum 5 days of hiring this van. So your answer is actually 5 rather than 5.55. Alright, we just have a couple more questions here. And now we're dealing with more than one unknown here. I'll show you how to do that when we work through this. So the first question says sausage rolls are this much, and then party pies are this much. And we're asked to construct a formula or equations of C, which is the cost of buying everything when we buy X amount of sausage rolls and Y amount of party pies. So what we know is that we want to set up an equation for C. The total cost is going to equal X amount of sausage rolls, and every sausage roll that we buy, it's $1.30. So 1.30x. It's going to give us the cost of sausage rolls, plus we also have 75 cents for party pies. So 75 cents is 0.75, and party pies are represented with Y. So this will be the cost of sausage rolls and party pies. Now, the next question says find the actual cost now. So find C when we buy 12 sausage rolls and 24 party pies. So C is going to equal 1.30, but instead of X, we know it's 12 now. And then instead of Y, we know this has to be 24 now. Now, obviously, you should use the CAS to solve this. And the way to go here isn't to use the solve function. We're not actually solving for any variables here. We have already set up an equation for C. And we just have to find out what this is equal to. So here we have 1.3 times 12 plus 0.75 times 24. So it's $33.6 is how much it costs altogether. Now this next question is very similar, so I'll go through it very quickly. So the total cost of lemon tarts, which is 3.5 each, and we're representing with X, plus apple crumbles, which is 4.75 each, and we're using Y to represent this. And we're asked to find the cost of 10 of these, and then 15 of apple crumbles, and then again just use the CAS to solve this. So 3.5 times 10 plus 4.75 times 15, it's $103.